Imagine this. It's a perfectly normal day. The sky is bright, but 150 million kilometers away, something impossible has just happened. The sun, the fiery heart of our solar system, has just vanished, completely vaporized into cosmic stardust. But here on Earth, you wouldn't notice a thing. The sky is still blue, the sunlight feels warm. Why? Because the universe has a strict cosmic speed limit. Science confirms that light travels at 299,792 kilometers per second. Even at that blistering pace, the very last photons emitted by the sun take exactly 8 minutes and 20 seconds to reach our retinas. So for 8 minutes and 20 seconds, humanity lives in an illusion, bathed in the ghost light of a star that no longer exists. But this cosmic delay isn't just about light. It is fundamentally tied to the very fabric of our universe. According to the theory of general relativity, gravity is not an instant magnetic connection. It is a physical warp in space-time. Massive objects like the sun create a deep gravitational well, keeping the Earth securely tethered in its orbital path, rolling along the curve. When the sun vanishes, that gravitational anchor doesn't instantly snap. Instead, the change ripples outward. This ripple, known as a gravitational wave, travels outward at the exact same cosmic limit as light, the speed of causality. So, while we are blissfully enjoying our ghost sunlight, the Earth is technically still curving around an entirely empty void. But the clock is ticking. At an observatory, scientists might catch a sudden, terrifying anomaly as solar wind data drops to zero. The countdown approaches 0. 8 minutes, 19 seconds. We are standing on the precipice of the greatest catastrophe, and then, at exactly 8 minutes and 20 seconds, the ultimate darkness arrives. The true horror begins. The 8 minutes are up. The last photon passes, and Earth is swallowed by the infinite, freezing darkness of deep space. The invisible fabric of space-time, once deeply bent by the sun's colossal mass, abruptly snaps completely flat. Without that central gravitational well to continuously curve our trajectory, the cosmic leash is finally broken. Sir Isaac Newton's first law of motion takes absolute control. An object in motion will stay in motion, in a straight line. Earth instantly flies off into the interstellar void along a tangential path, abandoning its circular orbit forever. We are now hurtling into the unknown universe at a staggering orbital velocity of 30 kilometers per second. In the dark observatory, our astronaut watches the holographic solar system scatter. The planets gracefully drift away like loose pearls. Despite this terrifying speed of over 100,000 kilometers per hour, you wouldn't feel a sudden jerk. Thanks to inertia, the atmosphere moves flawlessly with the crust. Earth keeps spinning, maintaining our 24-hour day. But dawn will never arrive. What about our closest companion, the Moon? Because the Moon is tethered to Earth's gravity, not the Sun's, it stays with us. Together, Earth and the Moon become a nomadic binary system, tumbling alone through the icy expanses of the Milky Way galaxy. We have officially become a rogue planet. Astronomers estimate there are billions of these orphan worlds, wandering our galaxy in absolute darkness. Now we have joined their lonely ranks. The beautiful blue marble is nothing more than a drifting, unmoored spaceship with failing life support. As the endless night sets in, the most immediate and devastating threat is not the vacuum of space, but the catastrophic collapse of the global temperature. The Big Freeze has begun. Despite the terrifying darkness, Earth doesn't instantly drop to absolute zero. We have a massive planetary insulation system. Our atmosphere and deep oceans function as a gigantic thermal reservoir, slowly radiating stored solar heat back into space. However, the thermostat is permanently broken, and long before the extreme cold sets in, the foundation of life crumbles. Within milliseconds of the sun's disappearance, photosynthesis completely stops. The biological engines of our planet power down forever. Without plants converting solar radiation into glucose, the global food chain experiences an immediate and irreversible collapse. In the first few days, the chill becomes noticeable. By the end of the first week, a terrifying milestone is reached. The average global surface temperature drops below 0 degrees Celsius. The entire planet is plunged into a relentless winter. Human infrastructure was never designed for an absence of solar heat. City power grids, overwhelmed by the extreme cold, begin to fail. Without the sun driving the evaporation cycle, weather systems collapse. The winds eventually die down, leaving an eerie, static silence. Yet, Earth is not completely devoid of warmth. Deep beneath the freezing crust lies a primal, churning fire. This internal heat is generated by the radioactive decay of elements like uranium and thorium in the Earth's core. This subterranean engine is completely unaffected by the missing sun. It continues to burn, oblivious to the cosmic tragedy above. But rock is an excellent insulator. That precious internal heat is far too faint to reach the surface and stop the advancing ice. For land-dwelling life, the surface has become a frozen tomb. The only liquid water left is in the oceans. And as the first year in the dark approaches, these massive bodies of water will face their ultimate freezing test. As weeks turn into months, the surface of Earth's vast oceans begins to freeze from the top down, sealing the waters below. By the end of the first year of our rogue journey through the dark, a terrifying thermal milestone is reached. The average global surface temperature plunges to -73 degrees Celsius, a temperature so cold it shatters steel. At these extreme temperatures, the entire ocean should freeze solid. But water possesses a miraculous, life-saving physical anomaly. Unlike almost every other substance in the universe, water expands when it freezes, making solid ice significantly lighter than liquid water. Because ice floats, it forms a massive, miles-thick physical shield over the oceans, rather than sinking and crushing everything. This frozen armor perfectly insulates the deep liquid water below from the absolute zero vacuum of deep space. Our explorer dives deep beneath the ice crust, entering a world that hasn't relied on sunlight for millions of years. For the strange creatures living in the abyssal zone, the sudden disappearance of the sun means absolutely nothing. Their dark, crushing, high-pressure environment remains completely untouched by the cosmic apocalypse unfolding on the surface. Because they do not rely on photosynthesis for energy, they rely on the beating, geological heart of the Earth. As the submersible scans the sea floor, temperature readings suddenly spike. We have found an oasis in the dark. Deep along the tectonic ridges, massive hydrothermal vents, known as black smokers, pump scalding water into the freezing ocean. These underwater chimneys are fueled by magma. They provide both the intense heat and the rare chemical compounds necessary to sustain life. Here, absolute darkness is no obstacle. Whole ecosystems thrive through chemosynthesis, a biological rebellion against the freezing void of space. Leaving the warm, geothermal haven of the deep, we return to the frozen surface. Years have passed in the dark interstellar void. The oceans are now completely sealed beneath miles of solid ice. But the cosmic freeze isn't finished with our rogue planet just yet. The atmosphere itself, the invisible blanket of gas that sustained all terrestrial life, is about to face the ultimate cryogenic test. As surface temperatures plummet past -78 degrees Celsius, carbon dioxide in the air begins to freeze directly into dry ice. A bizarre, powdery snow of solid carbon dioxide gently coats the icy landscape. But this is just the beginning of the atmospheric collapse. Our Penguin Explorer watches from a sealed, heavily insulated rover as the sky above undergoes a terrifying transformation. The familiar atmospheric glow is fading. At -183 degrees Celsius, a critical threshold is crossed. Oxygen, the very breath of life, condenses into a liquid. Pale blue droplets of liquid oxygen begin to fall from the sky. It is a surreal, beautiful, and absolutely extreme kind of cryogenic precipitation. Finally, the temperature hits -196 degrees Celsius. At this extreme cosmic chill, nitrogen, making up 78% of our air, condenses into liquid form. A torrential downpour of liquid nitrogen rain washes over the frozen continents, pooling into strange, alien lakes. Without solar radiation to keep these gases excited and expansive, The atmosphere literally collapses out of the sky, falling gracefully onto the planetary crust. The sky, once a brilliant scattering of blue light, becomes completely transparent. Earth is left entirely exposed to the raw vacuum of space. Without an atmosphere to create friction, cosmic debris and micrometeorites rain down, gently impacting the pristine ice without burning up in a protective mesosphere. Earth is now a perfect, airless ice ball, resembling Jupiter's moon Europa, tumbling silently through the interstellar dark in absolute zero isolation. The surface is lost forever. If humanity survived this creeping cosmic freeze, they would have had to look downward, into the very crust of the planet. To escape the cosmic vacuum and absolute zero temperatures, humanity had to dig deep into the bedrock of the planet. Welcome to the Geothermal Sanctuary, a sprawling underground metropolis built miles beneath the frozen crust. The secret to survival here relies on the geothermal gradient. For every kilometer we dig down, the temperature of the rock rises by about 25 degrees Celsius. Down here, the air is breathable, pressurized, and warm. The deadly vacuum of space is miles above our heads. The city is powered by gigantic geothermal plants. They pump water deeper into the hot mantle, turning it into high-pressure steam. That steam drives turbines, generating the massive amounts of electricity needed to run artificial sunlight and life support. Even our water supply is part of a perfect closed loop. Massive drills harvest the miles-thick surface ice, melting it down for the colony. And how long can this subterranean survival last? The radioactive decay in Earth's core will keep the mantle hot for billions of years. Physically, we are safe. But psychologically, humanity has become a species of moles, trapped in a gilded cage. Generations will be born and die entirely underground, never feeling the warmth of a real star on their skin, never seeing a real horizon. Above them sits an impenetrable ceiling of solid rock and miles of dead, frozen ice, protecting them from the cosmic void. But while humanity huddles around the fading embers of the Earth's core, the Earth itself has transformed into something entirely new. We are no longer just a planet in orbit. Earth has become an interstellar ark, a natural spaceship, carrying the last survivors of a dead star, venturing into the uncharted territories of the Milky Way galaxy. As our frozen ark ventures further, we cross the first true boundary of interstellar space. The heliosphere is gone. This massive magnetic bubble, generated by the sun's solar winds, once shielded our entire solar system from intense interstellar radiation. Without it, Earth is continually bathed in high-energy particles, traveling from distant supernovas and active galactic nuclei. But humanity remains perfectly safe. Deep underground, our astronaut monitors the surface radiation sensors with relief. Water is an exceptional radiation shield. The miles of solid ocean ice above act as an impenetrable armor against the cosmic storm. Years turn into millennia. Earth finally reaches the Oort cloud, the outermost boundary of our former solar system. This spherical shell of icy debris stretches up to 100,000 astronomical units from where the sun used to be. Unlike asteroid belts in movies, this region is incredibly sparse. Millions of miles separate these frozen ancient comets. Yet, Earth's immense gravity acts like a bowling ball, subtly altering the delicate orbits of these icy bodies as we pass. Once we clear the Oort cloud, we are officially in the deep interstellar void. The distance between stars is incomprehensibly vast, but in this absolute darkness, we encounter a ghost, a tiny, fragile piece of human history drifting silently. Voyager 1. Launched in 1977, it was our farthest operational spacecraft, carrying the golden record as a greeting to the cosmos. Earth, maintaining its rogue velocity of 30 kilometers per second, is actually traveling nearly twice as fast as Voyager. We gracefully overtake our own robotic pioneer. The Creator has caught up with its creation, only to leave it behind forever. Our rogue planet is now truly alone, a blind ship sailing away from our history, heading directly into the densest starfields of the Milky Way. Millions of years pass in the dark. Our frozen ark drifts through the Orion arm of the Milky Way, surviving the profound emptiness of the void. But space is not entirely empty. The galaxy is a swirling ocean of billions of stars, and Earth is a very small ship. What are the chances of our rogue planet finding a new sun? Astrophysicists calculate the probability of a perfect stellar capture is vanishingly small. Approach too fast, and we are flung back into the void. Approach too close, and the immense gravity will tear the crust apart. Furthermore, if we do meet a star, it likely won't be a yellow dwarf like our old sun. 73% of stars in the Milky Way are red dwarfs. Against all cosmic odds, an encounter begins. A faint crimson glow appears on the horizon of our frozen world. Earth enters the gravitational well of the red dwarf at the precise velocity and angle needed for a successful stellar capture. The rogue planet is a rogue no more. We have found a new anchor in the chaotic ocean of the galaxy. Deep underground, dormant surface sensors suddenly flare to life. The Penguin Explorer watches in absolute disbelief. On the surface, the first dawn in millions of years breaks. The extreme red radiation begins to interact with the nitrogen and oxygen ice. As the frozen gases sublimate, Earth rapidly regains its atmosphere. But this new sky is not the familiar blue. For the first time in countless generations, humanity prepares to open the heavy blast doors and return to the surface. The explorer steps out into a completely alien world. The sky is a deep crimson, dominated by an enormous dim red star. Red dwarfs are cooler, meaning Earth must orbit much closer to stay warm. The immense tidal forces begin to crack the global ice shield. It is a bizarre crimson dawn, but for the resilient survivors hiding in the crust, it is the ultimate victory. A second chance at life in the cosmos, but this second chance comes with extreme cosmic conditions. Red dwarfs are much cooler and fainter than our old yellow sun. To receive enough heat to maintain liquid water, Earth had to settle into a new Goldilocks zone, orbiting incredibly close. At a distance of just 0.05 astronomical units, this new sun appears absolutely massive in the sky, dominating the horizon. But there is a severe cosmic tax for this proximity. The intense gravitational pull creates immense tidal friction, eventually stopping Earth's rotation. This phenomenon is called tidal locking, a one-to-one spin-orbit resonance. One side of Earth faces the star forever, while the other faces eternal night. On the permanent day side, the endless solar radiation causes intense thermal evaporation. Massive perpetual hurricanes form over the boiling oceans. Meanwhile, on the permanent night side, the big freeze never ended. It remains a dark, frozen wasteland of solid ice and absolute zero isolation. Between the scorching day and the frozen night lies a narrow ring of habitable real estate, the twilight zone, or the Terminator line. Here the sun never sets and never rises. It hovers permanently on the horizon, casting long, dramatic shadows across a melting landscape. It is here that humanity builds its new surface outposts. Our Penguin Explorer maps out the new terrain, planting sensors in the thawed soil. If we were to grow plants here, they wouldn't be green. To absorb the dim, infrared wavelengths of a red dwarf, leaves would evolve to be deep purple or completely black. But life here is precarious. Red dwarfs are notoriously volatile, prone to sudden, massive stellar flares that dwarf anything our old sun ever produced. Earth's rejuvenated magnetic field, powered by the still hot core, takes the brunt of the impact, deflecting the intense cosmic energy. The result on the surface is a breathtaking display. Auroras far more intense than any northern lights dance across the entire twilight sky. It is a harsh, bizarre, and volatile existence. But as our explorer watches the sky burn with color, one thing is certain: we survived. This new crimson world will never be the Earth we once knew, but it offers something our old yellow sun never could: practically infinite time. Our original sun had been burning steadily for 4.6 billion years, and it only had about 5 billion left before expanding into a red giant. But red dwarfs burn their nuclear fuel incredibly slowly. This tiny star will continue to shine stably for trillions of years. Long after all the massive yellow and blue stars in the Milky Way have exhausted their fuel and faded into darkness, this red sun will still be keeping humanity warm. Standing on the edge of this new frontier, our explorer holds a small holographic projection of the old, bright yellow sun, a ghost from a forgotten epoch. We must never forget the star that birthed us. Every atom of carbon in our bodies, every trace of iron in our blood, was forged in the fiery hearts of ancient stars that gracefully expanded into glowing stardust billions of years before our sun was even born. We are quite literally star stuff, inextricably linked to the immense, beautiful mechanics of the cosmos. Our harrowing journey through the infinite dark taught us the true scale of the universe and reminded us of the billions of rogue planets still wandering blindly without a home. It reminds us of the profound fragility of our oasis. As astronomers once noted, we are just a mote of dust suspended in a sunbeam. Whether that beam is bright yellow or deep crimson, it is the only thing standing between us and the absolute zero of the cosmic void. The disappearance of the sun was the ultimate apocalypse, but it was also the ultimate lesson in cosmic humility. We are not the masters of the universe. We are its incredibly lucky passengers, riding on a speck of rock through an unimaginably vast ocean. As our explorer gazes out into the alien sky, the red dawn breaks once more, a symbol of ultimate endurance. The universe is terrifying, vast, and uncaring, but as long as a single star shines, life will find a way to keep looking up.